Hello, everybody, and welcome to today's Black Hills Information Security Webcast. With me today is Hal Denton. He's a part of our SOC team, and you're a detection engineer lead.
Yeah,
So
I guess you could call that.
you detect things, you engineer the detection of things.
Yes. All
Okay.
the malicious things belong to
Yeah.
me.
Yeah, so sometimes people don't realize that Black Hills has a SOC service, and then in our SOC service are professionals that do SOC service type things like Hal. And so I reached out to all the people who work in our SOC, and I was like, would you like to give a webcast on the work that you do that makes it better for our clients, that makes it better for the industry? And so Hal, it was like, yeah, I got it. So you did a webcast like 2 weeks ago with Paul. That was fantastic. And then Hal had he's like, and I got this other idea. It's about EchoThreat. It's a tool that you've written, that you've created that makes your life easier, and you're releasing it now for everyone to be able to use. So when I was talking with you, there's like an excitement to not only the tool that you made, but the work that you get to do, and so how it all comes together. And so hopefully, as people are listening and watching today, they'll get a chance to like, is this a tool that works for them, or is the technique and the methodology something that can work for them to improve their life as a detection lead, or someone who works on the SOC that has to figure out how this stuff works. So everyone, please, Hal is here to share his knowledge. And if you have questions at any time, feel free to ask inside the Discord server. The community might be able to answer your questions faster than Hal can get to it. You can also ask your questions here in Zoom, because if you can't use Discord, we totally get it. And other than that, Hal, it's all yours. Are you ready?
Yes, sir. Let's do it.
All right, I'll be back for Q&A, and if anything goes wrong during your demos, not saying it will, but if anything goes wrong, I will definitely chime back in while you try to fix things, if that is something that needs to get fixed. All
All
right, I'll
right.
see you in a bit.
All right. Thanks, Jason. All right. So let's get started here. I just want to thank you for coming out today. I put a lot of time and work into this tool, and I'm really excited to share this with you guys. So let me tell you a little something about myself. I'm Hal Denton. I've been doing the things for like 20 something years, involving IT and security. Most of my career has been in security, but in the past 5 years, it's mainly been focused on detection engineering and DFIR, so this digital forensics instant response. So I'm a husband, I'm a dad, and just I'm simply a human. I'm just like everybody else, but I chose to come out here and share with you guys, and hopefully I'll motivate you to do the same thing. Also, some of my hobbies is just trying to be a cool, fun dad. I don't have anything too elaborate that I do. I mean, sure, I do some 3D printing or what have you, but that's mainly all geared towards my kid. Like I make toys for her or little jewelry boxes just to make her day. So that's a big thing for me, is ensure that my kid has a good quality of life. Also, I want to do a little special shout out to her. Today she is graduating. So I wanted to just say I'm proud of you and I love you. Also, the creator of EchoThreat. So again, I put a lot of time into this. I hope you guys like it. Also, I want to take the opportunity to let you know that I'm putting on a course in the future. It's called Detection Engineering Unleashed, and I have around 7 modules with there's about 3 labs per module, and it covers Windows endpoints, Linux endpoints, cloud, and a little bit of networking. But if there's something in particular that you have a high interest in and you want to know about, this is a great opportunity to share that with me, and I might be able to fit it into my course. So if you have any type of feedback, I would love to hear it. So I always like to try to give like a story, right? So I'm gonna give a little bit of a backdrop of what came to pass for this tool to even happen. Then I'll go into a little bit of discussion on detection engineering, and then we'll go into the tool, and basically I'll have a demo at the end. So just bear with me. I like to build it up and then like, drop the mic on you guys. So have you ever wondered about AI? Like if you haven't been using AI or like what's this buzz about AI? So I did an experiment with myself. I'm an old curmudgeon, grumpy old guy, and like, what's this new thing everybody's talking about? Well, I tried it a couple years ago, and I didn't really like it. There was a lot of bad information that it was providing me. But a couple years later, like, well, let's try it again and see what I can do. I have a lot of past experience in coding, so I've written in C Sharp, PowerShell, Bash, Python, all those random languages that you typically would write. I've written scripts. I've written production level software. I've done all those things. So it's not like I don't know how to code, but I haven't heavily coded in 5 years. So with that, I'm kind of rusty. And what better opportunity to basically try to use a new tool, which is AI, to basically sharpen my spear. So I took that as a challenge to myself to see what AI is all about and what it can really do for me and for everybody else. So this is not necessarily the best model that I used. I was just trying to figure out my flow, but I had two different models that I was using. One I used as like a third party consultant or like a scrum master, keep me on task to do all the development that I need to do, everything that I've been talking to it about. Like, here's all my ideas. This is what I want to do. Can we make this thing? Can we make it together? Type of thing. Can we make it fast? The second model that I used was specifically for coding. So I would have all these conversations with the first model and like we'll come up with a game plan and we might alter it and then like, okay, let's put it to code. So I would take that prompt and send it to the other chat, be like, hey, write this code for me, please. So he's like my personal software developer. And whatever he would produce, I would basically look over it and be like, does this make sense? Does it even work? I do the testing. I check out what type of error I was getting, see how it's actually working. So at the same time, I'm using AI to write some of my code from my ideas, but I'm also taking what it created and trying to rehash what I've lost over time. So like basically I'm retraining myself on how to write code again in Python. And I spent tons and tons of time doing this. I probably spent way too much time, but I learned a lot. And at the end, what's my final thought on AI? From that grumpy old guy perspective. Well, I am happy to say that it is a tool in my toolbox nowadays. Now I feel like other people should take the time to learn it and find the right workflow for yourself. So it suits your needs and what you need to do for some of your tasks. Maybe it's personal tasks or work tasks, but the power behind AI and what it can produce for you if you're obviously watching what it's producing and checking it, and that's the other thing I would advise is almost like debate it. Like, hey, what? I'm not sure about this. What about this type of idea? Or I don't think that definition is quite right. What about this? And then you go back and forth, but don't be afraid to challenge it either. So it is definitely a tool in my tool bag. All right, so now we're kind of moving on. So that was kind of like the backdrop on how EchoThreat came to be. Now I just want to fill in a couple of dots if you're new to detection engineering. So I want to talk about the role itself. So we kind of touched on it a little bit earlier when we did the intro. So a detection engineer's primary role is to create content that detects malicious activity. And that could be in various forms. It could be for in a SIM, it could be in an IDS, it could be in an IPS, whatever tools and solutions that you have in your environment, that type of person can take that and create content for it to detect the malicious behaviors. Now, when we think about how that role is aligned to an organization, highly depends on the organization. So when I say that is, what does the organization do? What's their staffing? Like, do they only have one person? It doesn't really make sense to say you're in this particular department, but you're one person that has to do everything else. So the size of the staff matters, uh, and also there's some other areas that you might need to consider where that engineering role needs to be. But overall, it just really depends for that organization. The role typically includes doing lots of research, right? We try to figure out what those TTPs are, what's trending, what's those current 0 days, how are we getting attacked, why are we keep getting breached with business email compromise. So let's figure out a way to detect that and stop it. So it's a lot of data analytics that are involved. And then when we talk about DevOps, it kind of borrows the concepts from software development and using that as detection as code, so we can push out our detections out quickly. All right, so just real quick, with every type of process, there always has to be a life cycle. So there's typically 7 phases. I put this together myself, just trying to simplify and have something to work from. There's technically not a unified model out there today, so I put this out there for us to utilize. And I probably should have came up with some type of fancy abbreviation for this, but I wanted to make it just make sense. So there's the collection phase, there's the research phase, the validation phase, verification, release, maintain, and measure. So those are all the steps that are required to basically create, deploy, and monitor your detection once it's been deployed. And today we're mainly going to focus on verification. Like, what can we do for verification? And if you want to get a more in-depth conversation on the detection engineering lifecycle, 2 weeks ago, me and Paul Lammers did a webcast on detection engineering alert disposition. So that's already out on YouTube. So if you want to get a grasp of what that is all about, feel free to look at that. So, a verification phase. What is the verification phase all about? Uh, just to sum it up, once we have our detection and we have an idea what we want it to do with it, we want to make sure that it can fire in our SIEM, our alerting mechanism to make sure it works. So we did all this work to create the detection, but we want to make sure that it works. We want it to trigger. We want to verify. And there's a couple of ways that we can do that by using different types of test types. So there's a burn-in method that you can use, which is where you set up your detection to not send alerts to your SOC or your responders. So it's basically just pre-stage. The SIEM is taking in its normal logs, and if the right telemetry comes across the wire, it'll fire. And that normally takes a burn-in period time, like whatever you decide is appropriate for your organization. Maybe it's a couple of days, maybe it's a week, maybe it's 2 weeks, what have you, but all that takes time. And then the other test type is trigger scripts. When we talk about trigger scripts, you can kind of think about how Atomic Red Team works. There's a framework of scripts that fire off particular techniques using tools and actually launching the codes, or scripts that make that behavior of that telemetry. So this is a detection engineer creating that trigger script that's like an Atomic Red Team script. And then there's actually, performing the attack. If you have internal red teams, or you hire a red team, or you hire a third-party pen testing company to do some of that, you can use that as a way to verify some of your detections. All right, so what's the deal? What are we trying to do here? So all this stuff takes time. So the problem is, it takes a lot of time to get our detections into production. Um, so there's various different types of things that require or delay that process. So how complex is the TTPs you're trying to detect on? Do we already have that telemetry? If we don't, that's going to also make another delay. Like if you have to onboard a new data source, that's going to take time. Uh, what was the test type that you use? I just mentioned some of the three that you could use, but all those different things take time. And then after you get all that, you have to go to peer review. Somebody has to, get that second set of eyes to determine, like, is this good? Will this overwhelm our responders? We have to make sure that we're not just throwing things over the fence. So what we're trying to do here is, how can we expedite or decrease the time it takes to get these detections into production? So here we go. Let's take some control. When I say take some control, all those areas that I just talked about, one thing that we can do as a detection engineer is expedite our verification process. So a lot of those other ones are dependent on development time to make a script, or external teams like red teams or pen testers or purple teamers. And then the burn-in one, that's just waiting, period. Like you just have to wait for it to fire. So that in itself takes time. And some organizations might not like frameworks like the Atomic Red Team, right? Because the Atomic Red Team does bundle up some hack tools, and you might have to disable some EDR type of solution for it to actually work. So some people might not like that. So this is what I'm suggesting that we do. If we're taking control of the verification phase, we're in control of that. And one of the test types that we can start utilizing is simulating logs. When we simulate logs, you know, we are basically saying that this is what I want to alert on based on all my research that I did previously. I know what telemetry is going to be generated. So if I can take that research information and put it into a simulated log to verify my detection that I've built, we're winning, right? We're decreasing that time significantly to get those detections out there. We can move faster. So I always wanted to make some type of pyramid diagram. There's a lot of good ones out there when we do incident response. We're filtering down the data to get to the conclusion of like, is this malicious or not? Or we talk about the other types of pyramids. When we talk about the pyramid of pain. So this is my spin on a pyramid, and when I'm talking about the verification cost, the verification cost is something that we need to think about. Time versus authenticity, right? When we talk about that, is it really worth getting 100% authenticity? Well, let me explain this diagram a little bit. So going from the bottom to the top is the level of authenticity required uh, by each of these different layers, right? So we have our simulated logs, we have our burn-in detection, we have our trigger scripts, and we have our performing attack, right? The higher we go up, the more authenticity that we have. So if we go from left to right, looking at those layers, what do we have is time. How much time does it take to basically create or verify our detection is working? So to me, we all have to weigh what's the cost. Because when I say cost, time is cost, right? It's cost on man hours. It's cost to the company's risk if we're trying to deploy something that needs that verification check. Time is money. So, and not all detections require full authenticity. So let's take advantage of that. So we're here to talk about a tool. So it is EchoThreat. And I wanted to give you kind of an idea how it all works. So looking at the diagram on the left, basically just manipulating my way into this by using what's already probably in place in your organization. So I'm injecting myself into this. So EchoThreat is injecting itself into the flow. And typically, every type of SIEM or alerting mechanism has to collect logs at some point to get that telemetry. So if we think about EchoThreat is injecting its custom log that log collector is just going to absorb and is going to send it to the SIEM. So when we talk about log collectors, there's several different types depending on the SIEM that you have. So talk about Elastic Agent with FileBeat, or we have the Splunk Universal Forwarder, or if we have like something like Lima Charlie and they have like adapters. Those are all things that we can basically inject our simulated logs in and get it into our SIEM. So the level of entry is very small to do this. I try to make this very lightweight on like burdens. And we talk about costs and stuff like that. How can I make a very small dependency on making this thing work for everybody? So on the right side, this diagram is the overall structure, the directory structure of EchoThreat. So there's basically makes up 6 folders. Each folder has a meaning, and we'll go into those a little bit more in depth. I'll try to make it quick because I do have a demo at the end. But there's 3 main scripts. There's the EchoThreat PY. That's basically the core, and it talks to the other libraries, which is Windows Log Generator and random PY. And I'll talk to what all those mean in a minute. So let's break down the flow a little bit of how EchoThreat works. It's simply, it takes input and gives you output. I mean, it's very simple. So I designed it in a way that you can use it by CLI. You give it a bunch of arguments, and those arguments tell what's your log source, or what event ID do you want to use, and what's your format you want to use. So when I say that, behind the scenes, I have a bunch of YAML configuration files that's basically help define values that you want to inject. And then there's also a Jinja template that those variables get dumped into. So that all that gets crunched by EchoThreat and all its library dependencies and just spits it out to that custom log, which gets ingested by your SIM. So this is all Python based, and just currently it only supports Windows, but I have plans to expand it. And it only currently supports Elastic, but this it's an easy fix. I just have to have the time to develop the other connectors and what have you, and logs. So once I get this is the core workings. The core workings work, and now it's just about adding those other little modules. So let's see, where is the YAML files? Yep. Okay. So one thing that's kind of unique, because when we think about, well, you're just using templates, man. Like, what's so cool about that? Well, to give it more authenticity, we need some randomization in our templates. So that was the core reason why I'm using Jinja, is because I can basically inject randomized code into these templates with that random.py script. So that's kind of some of the fancy part of it. The output, you can think about it as in three different layers of testing, right? When you're creating a new template or a Jinja template, you want to see how it looks. So using standard out gives you a way to see what it's going to render like. Is it taking your data correctly? Does the format look right? So that you just print it out to standard out. And once you're comfortable with what that looks like and the data that's being rendered correctly, then you can take it one step further, and that is writing it to disk. That doesn't necessarily mean we're going to consume it in our sim yet. We actually have to send it to our actual log collector. So in this case, right now, it supports FileBeat. So once I use the output command that says FileBeat, it's going to send it to that directory that's being monitored by the log collector, and it's going to send it off into to the sim. So I'm trying to give you layers of comfort before you start sending data to your sim. Okay, so EchoThread itself. This is the glue that keeps it all together. Back in the day, we used to call this like the handler script. And some of the power here is we could just generate one event, which is not that fancy, is just one event. But when we can start adding additional layers of functionality, like, okay, I want to generate multiple events in one shot. Or if I want to chain different types of event types together, I can basically simulate when a process creation happens that has a follow-on action to do C2. I can basically say, hey, there's a process in execution, and there's followed by a sysmon type of event. This would typically happen for this type of binary. I mean, I can basically simulate that. Or we can take it a next step further when we talk about correlation type of rules. I can basically shoot off a bunch of different types of event types to simulate what I need to correlate for my rule. So I also, like I said, I'm trying to make this very scalable, flexible, and easy to use. So I also added the ability to do detecting on the configuration files that you set up. And that I basically was able to do that with a naming convention. So when we talk about those user defined YAML files, which is the data that you're inputting, and the Jinja templates, they use a naming convention. So when you're using those CLI arguments, they know what to select. The code knows which ones to grab to join them together. And if you're testing out something and you don't want to like put it in that naming format, there's another switch, just -C, to say, I want you to take this template or this configuration file. I want you to use that. So if it's something outside of the norm, then you can still say I want to use this with that -c command. And also there's the ability to make things realistic, which is throttling, right? If I were just to run this, it would just basically fire, right? Super quick. That's not realistic because it takes time. There's time in between certain events that happens. So we need to make it realistic. We need to be able to throttle those events between one another. All right, so I'm going to go into like all the directory structure, but I'm going to try to go through it kind of quick. So I'm just going to touch on it a little bit. So the configs directory, I keep talking about these YAML files. So the configs directory holds those YAML files where you define the values for those fields. When I say values, what's the username? I want to define that in my YAML file. What's the host name? I want to define that in my YAML file. What's the process path? I want to define that. What's the IP? What's the source IP? What's my target host? Any field that you can think of that you wanted to be populated, you put it in your YAML file. Okay, and so since this is kind of Elastic based, I follow the Elastic Common schema, which is having standard naming for your fields. So it follows that naming convention. And then all this data from your config file gets shot into your Jinja template. All right, templates. So this directory holds our Jinja templates, defines the overall structure of that template. So we want it to be authentic as possible. So a lot of this is designed in JSON. So when we talk about the field names that match to the field naming conventions, we want it to align to that SIM or that product, that solution. So we want to align that. So when we talk about advancing this product, let's say like Splunk, I'm going to use their for what's called like CCM or CMM, their naming standard. So the templates would be based off of that, and the config files will be based off of that. Earlier, I talked about it will detect your configuration files and the templates. So the naming convention is just log source followed by event ID followed by the format. When I say format, that's is it Elastic schema? Is it Splunk schema? Or do you need randomization or what have you? So an example of this, so to give you a little tease of the tool itself, pretty simple. EchoThreat.py -ls is our log source. So I'm specifying the security log source. -eid, this is the event ID 4697. -tf, that's the template format. I'm using Elastic. Where am I sending it? Am I sending it to standard out? Am I sending it to a file? Or am I going to send it to my log collector? I'm going to send it to my log collector, FileBeat. All right, I keep saying Jinja, but are you like wondering if I'm saying Ninja? Because the things that we do as cybersecurity professionals, everybody kind of thinks, oh, you're that ninja guy that does computer stuff. So yeah, I am saying Jinja. And it is kind of an interesting name. It derives from a Japanese word and that translates to English as a shrine. So maybe once you utilize Echo Threat, maybe this will be your shrine. I don't know, but we'll see. Uh, so the point of Jinja is allows you to do coding in your templates. So I can when I say that is when I pull on that random.py script and I have different functions in there. I can randomize the host names. I can randomize the usernames. I can randomize IPs. I can randomize source ports. I can randomize service names. I can randomize anything I want. That's the power of Jinja and integrating that into Python. So the generators directory. So this holds the windows.log or windows dash or underscore log underscore generator py. And that's what's crunching everything together, doing the rendering from the Jinja templates, and then sends it off to be written. And then its overall function is the generate underscore log. I'm hoping As I continue this, I want to add some Linux generators. I want to add probably the audit D generator. And when we talk about cloud and 365, I'm going to do a generator for that too. To speed up some time here, I did lump these two directories together. We have utilities and output directory. So we talk about outputs, it's output, right? We're sending stuff somewhere. Uh, and when we're writing to disk, everything's being written in ND JSON file format. And then we talk about the utilities folder. It holds the random.py script and uses that ran function and is responsible for all the random things. So when I was putting this slide together, uh, I was trying to find some gifts because I tried to limit as many gifts as I could to try to like help focus the conversation. But I'm at the point where I need to do some gifts. So I was looking for something random, and I think I found the most random thing that I ever seen, and I couldn't stop laughing. So uh, I don't know what's up with this, like whoever created this, but when I first saw it, the first thing that came to my mind was "Beat 'em Bumbleweed." So I know you guys think I'm like so weird right now for finding a GIF and like doing this, but I just couldn't help laughing in the middle of the night, and I was just like, I thought I was gonna wake up my kid and my wife, but I wanted to share that, and hopefully I made someone's day with that, and got a little giggle out of you. All right, so moving on to the presets directory, it holds those predefined YAML configuration files. So when we talk about this one, it is like the master YAML file. It's responsible for allowing you to do chaining of events. So we have those user configuration YAML files. This YAML file can read those YAML files to basically say, I want you to do everything I want for this event, this event, this event. Just fire it all off. If I want you to fire 30 events for this one event ID and I want you to throttle it for like 2 seconds, you can specify that all in these presets. And this allows us to also throttle them. So it has that sleep mechanism in there too. So this helps you with tuning, and it also helps simulating that attacker behavior. All right, my favorite part, demo time. Hopefully you're still here with me. And this is my favorite part because you get to see everything work. All right, so, and to make this more realistic, since I do digital forensics and incident response, I took some of the data points from an IR that I performed. So this is firsthand observations of attacker behaviors. So I will caveat that the IOCs, like the IPs and domains and users, they're all fake, right? They're all generated. I'm not going to share any of that type of information. But the behaviors are realistic. This is what I saw, and we're going to basically simulate those. So the short story to this is a user downloaded a utility from the internet, right? They're having some type of computer problem, and they're like, "Oh, I'm going to download this tool and I'll fix it myself," type of thing. And lo and behold, they end up downloading Cobalt Strike. Oopsie daisy. So insert IR, giddy up, here we go. All right, this one I gotta switch screens here 1 second. Boop, boop, boop. All right. So this is in the slides that should be published, but let me do a quick change of sharing. My meeting is being recorded. Okay, 1 second. All right. So when I give you a little, can you guys see my web browser? Yeah, okay, it looks like it. Okay, so this is Elastic. All right, I have a bunch of rules in here that are set up. So I need to do some verification, right? Um, I want to mimic the behaviors that I saw in that IR, and to show that I'm not pre-staging anything. It's the last 15 minutes, and this is our alert. So it would give us a summary of any alerts that have fired. There's nothing here, right? Okay, and just to give you a quick look at some of the rules that I put together. I'll go into more detail in a minute. But so I have one, two, three, four, five, six types of rules here, pre-staged. They're all enabled, and they're ready to go. I need some verification. Let me go back to our alerts real quick. All right, let me switch to my other screen. All right. So I do use VS Code to do all my coding. And how I have this set up, I am SSH'd into a AWS instance because I don't want to necessarily do all my dev work. I want to do it in a safe place for now. So there's a AWS instance that are out there that I'm SSH into. That's where my scripts are. That's where my test Elastic instance is deployed. So I have my log collector out there with my file beats integration enabled, and it's basically looking at the output directory for EchoThreat. All right, so here's the directory structure I talked about. Here's all the utilities. Let's see what happens. So the first, so let's talk about the techniques that are being used. So the utility that was downloaded was a zip file. So when typically users download a any type of file, it typically goes to the C users, whatever that user name is, downloads. So I'm gonna look for something that is a zip. So let's simulate that real quick. So we have our Python, we got EchoThreat, .py. Let's specify our log source. We are -ls. And we want to do a sysmon event. And we want to do an event type of 11, right? So that's basically file creation. And we want to do the template format of Elastic. Well, you know what? Let's simulate or standard out, right? What does this look like? Is this thing even going to work? So how I made this was basically to provide information. I probably have a typo here and I have to figure out what I typed wrong. Um, but so we have our information, the echo threat started, what's the log source that's being used, that's sysmon, and what's the output being used, standard out. It detected the configuration file, but I have an error here. It didn't find my Elastic template. So let me see what's going on here real quick. Oh, because I misspelled. So Elastic -o standard out. Right. So now that I'm running this, I have all my configuration files set up. I have my Jinja template set up, and I have it all formatted to how Elastic likes that data. So this is what it actually will look like. When we think about the ECS schema, we have our event dot type, which is a creation event action. It's file create. What's the event code? It's 11. When was it created? So that I have this in code to basically generate once I run the command. Because on ingest, I don't want some old stale date that I have to search like 5 or 10 or 2 years ago, however long you started using the tool. It's dynamic. So when you run it, it's on runtime. So when I say what do I see in the last 15 minutes, it's going to give me that. So that's what that is all about. So I'm getting that idea. And of course, Tommy Boy, he's always a problem child. So of course, we have that. And he downloaded, or he's going to download the evil.zip. All right, so let's send it off to our sim. So I'm going to just change the output to file beat. And here we go. It's done. All right, so let's move along on the IR scenario. Let's see. So after the user downloaded the utility, installed it, and ran it, all of a sudden there was a C2 that fired off. Stop these slides real quick. 1 second. Okay, there we go. So after that, there's basically a C2 that got fired off. Okay, well, let's simulate that too. Like, what does that even look like from a log perspective? Well, we know is basically what's the destination port or destination IP that specifies that there is a connection, right? So we want to use our sysmon event, because nice and handy dandy. .py. Our log source is sysmon. Our event ID is 3, which should be our network communications. And then we're going to use the same template format. We're going to use Elastic. And let's just go ahead and send it off to file beat. Yeah, that's it. Okay, so there we go. We're already done. It's already simulated based on us pre-setting up our YAML configuration files and our templates. The templates you shouldn't have to change too much, but if you do, you just basically duplicate and you change what you need to change. So there's nothing too fancy right now, but let's make it a little bit more complicated. So let's move on to the next type of event that we want to simulate. So when we're thinking through this IR engagement, we have the C2. All of a sudden, I see all these massive logon attempts from this one particular user, right? This is patient 0. Um, what is going on? This is all these successful logons to all these different hosts. Why would that even happen? Well, when we talk about that initial foothold, the attacker doesn't know where they're at. They don't know what that user can do. And one dance move when I see something like this is typically when they're trying to figure this out. They want to use a tool like SharpHound. And when they use SharpHound, they're enumerating and they're trying to figure out all the different things this user has access to. Are they administrator? What's the quickest path to domain admin? How can we get there? As when I say SharpHound, that's just a subset tool to Bloodhound. Bloodhound is just the graphical GUI that gives you all those relationships. So we have this massive logon from this one user. Can we simulate something like that? Of course we can, because we have EchoThreat. So let's do this real quick. So we're going to change up our log source to security. And our event ID, we're going to do our 4624s. Our template is going to be Elastic. And I talked about randomization, and from what I saw from an IR perspective, it's being generated. The source host was being enumerated, so there's tons of different hosts that are being accessed from. So we need some randomization. So I talk about that rand and naming convention. So I'm adding underscore rand, and I want to basically randomize my hosts. And we're just going to send it off to FileBeat. Okay, cool. But that takes more than just one event, Hal. So how are you going to do that? Well, I have another switch for that. So it's dash CNT for count, like how many events do I want to be created? I'm just going to do 30. I could probably make 3,000 or 3 million or whatever you wanted to do. We can do that. And that's why it's so flexible and scalable. And what's this dash th thing about? So that's my throttle. Uh, and when I talk about throttling, that's that delay, that trying to give that realistic feel in between each event. So I'm just going to do, a point two. Point two is kind of realistic from my perspective when reviewing the response. It was like, I think it was like 300 hosts that enumerated from, and geez, it was all within like a minute. It was ridiculous. So let's do it. So as we see this output, it's giving me information. It's giving me a incrementing count of how many events. It's showing me where I'm writing my log to. So we talk about that output directory. Let me see over here. I'm a stickler for structure. So here's the events from earlier. Here's our sysmon. Here's our event ID, and I even added a timestamp to help me verify that what I'm doing is working. And I also have it that to minimize the amount of files that are being written to disk. Some of these will have multiple events in it, just like this one. So I don't have 30 files created now. And we can see some of the stacking. So since I talked about the randomization of hosts, let's see what this kind of looks like here. So here's some of my hosts here. Here's my host name. These are all different. Different. Pretty cool, right? I think it's cool. So that's that. All right. So let's move on to the very we're getting closer to the end. We have our malicious dropper, we have the execution, we have network communications, we have these mass logon events from this particular user. And now, with attackers, they always like to stay in their environment as long as they can. So they're going to deploy some type of persistence mechanism. In this instance, I saw a service name creation. So we have new services being deployed across all these different endpoints. So how can we do that? How? That sounds ridiculous. Well, I mean, like I said, we have this tool called EchoThreat, and we can do that. So this is just going to be another security log source event. So we got our log source security. Let's change our event ID to 4697. Right, 4697. And then are going to change our template format. And this, all this is still elastic. And we're going to do a randomize function again. And we're going to say we want randomized service names. Because when these guys were out there, they were deploying, you know, so basically I recognize a pattern. That when they deployed their tools, the service names was randomized and it was a certain pattern. And I picked up on that pattern. And because I picked up on that pattern, I was able to basically identify everything that they deployed. So service name, I want to randomize. I'm going to send it off to our log collector. I don't necessarily have to do multiple ones, but why not? So we do at least 15 events. I'm gonna do the same type of throttle, 0.2 seconds. Boom, 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 boom. Doing my generation, getting my verification, baby. Let's go. That basically generated a bunch of events, 4697, that says, hey, I have this new service creation. The service names are randomized to that pattern that I identified. And the executables are being randomized too. I didn't really show that here, like in the naming convention, but behind the scenes, I know I set that Jinja template to do that. But that was pretty quick, right? What? That was less than 3 seconds. Bam. Okay, so let's wrap this puppy up. So I talked about single events, I talked about multiple events, I talked about throttling events. But what if we want to do a attack chain or we want to do a correlation rule? We want to have that ability at our fingertips to validate some of our more complex logic. Well, we can. Let's do it. So I talked about those presets. And that's taking my predefined user configs, like the values. It takes those predefined Jinja templates. It's like that grandmaster YAML file to rule them all. It's the grandmaster. So let's do this. So Python, EchoThreat. I don't like X or spaces. EchoThreat.py -p saying, give me my presets, man. So what we got? Presets. Man, I should just like do autocomplete, but that's not realistic. Presets. I'm gonna do my chain. What's my attack chain going on here? I'll just do that. Okay, and I wanted to send it to FileBeat. So all that stuff that I just did manually, I could do it in one command. Ready to do it? Let's do it. Boom. So it's just going. Boom, 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 boom. And this only really takes less than 7 seconds to do. And I basically generated a whole attack sequence, right? That's ridiculous. Like, I mean, the time that we're decreasing in our verification is like phenomenal. Uh, so we basically generated all those. So I'm going to pivot back to Elastic. Earlier I showed there's no alerts. There's no alerts there at all. So let's see what happens. Did we get the verification that we needed? That's the question. Dun, 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 dun. Okay, so in Elastic, there's a alerts dashboard, so to speak, that kind of summarizes all the alerts that you have. This is a test instance, so I mean it's nice and clean, so I can show like this works or doesn't work. And I don't have many alerts here. Oh man, what's going on? Well, I always got to refresh my screen. So it lasts 15 minutes. What do we got? Got 23 alerts. I mean, that's a lot because I don't have suppression enabled on any of my rules. So, I mean, I just basically verified those 6 rules that I showed you guys earlier that I staged to like, I need that verification. Is this thing working? Does it meet my criteria for everything that I did my research on? It does. Look at all that. It's just beautiful. All right. So let's go into, how are we doing on time? Let's go into our rules real quick. I have these pre-labeled to basically show some of the logic. Right? I'll skip over number 2 just to save time, but to show how simplistic this first rule is. It's like the basic string match. Um, let's take a quick look at it. All right, so I'm just basically saying the event code 11 with the file directory for users. It doesn't matter what their username is. Downloads with a file extension of zip. Pretty basic detection. So let's go to the next one. I'm going to skip number 2 because that one's pretty basic too. So I made 2 for the mass logons. So Elastic has 2. Well, they have several different languages, but for their detection mechanisms, when I talk about thresholds, it's basically a statistic or a number that's being generated based on the syntax you gave it. So once it reaches that threshold, that number, it goes beyond that number, it will fire. I'm not necessarily a big fan of that in Elastic when we have ESQL. ESQL is super powerful, so I'm going to show you that one because again, I come from the land of Splunk and I love SPL, and ESQL is basically starting to mimic that a lot, and I'm really liking it. Go. Here we go. So ESQL is like if you're familiar with SQL syntax, when we think about the from here, the from is saying like, hey, what's the table that I want to look at? And I have this set up for the logs EchoThreat. So everything that I'm ingesting from EchoThreat's going to this particular index. So what does that mean? That's not realistic, Hal. Well, we are testing, we're doing our verification, but our logic is not going to change except for that index, and that's easily changeable. So once we have our verification, we just change our index to match the proper index that we need to use. So that's the data that we're selecting. When I say pipe, is basically I have this data, and now I'm going to send it over to this next command, where I'm saying where is basically our matching condition, event code 4624. Okay, that's what I'm matching on, event code 4624. And now I'm going to pass that over to my stats, which is a way to do statistics, right? So I want to do some calculations. I want to crunch something. And this is one of my favorite dance moves, and I've done this for a very long time, is I always add a first time and a last time, especially when I'm stacking data. First time, you're using some of the functions inside of stats called min. So I take that timestamp and it gives me that first time that event has been seen. And then I do last time, which is the max function for timestamp. So I get that first time, last time. So I have basically a range of information there. When I say volume, that's just basically a count of events that have come in the period of time that I set this rule for. Host cardinality is the variance or the difference in the host names, like the unique host names that are being crunched from that execution run. Like, well, give me that unique number. And then I'm stacking it all by username. So I'm taking all that data, the 4624 events. I am giving me the first time, the last time, how many events have come in, how many unique accounts have occurred, and I'm stacking it by that user. So we talk about Tommy Boy, that troubled child that always doing those weird things, and piping it off to my next condition, the host cardinality count. So it's just a number. And is it greater than 25 hosts? If it's over 25 hosts, then it should fire. So in our EchoThreat setup, we did 30. So we just fired off 30 events, and that basically validated my logic works. All right, so let's go to some of the other ones. All right, so trying to get layers of complication in our detection logic. A lot of folks like to use regex, so we have to have regex as a way to make sure that we're detecting all the things. And of course, during demo time, I get an error. Let's see what happens. See if I can recover quickly. Please hold. Do 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 do. All right. So thinking maybe yes, come back. Come back to life. Loading, loading. PC load letter. All right. So this is when we're simulating the randomization of hosts or not hosts, randomization. Well, we were doing hosts, but also the service names, right? That's that persistent mechanism that was deployed by these threat actors to keep themselves inside their network. So using the event code, this is EQL in Elastic. So their language is slightly different, but it gives me the power to use regex. And so when I say any, it's basically any type of alert that or a type of telemetry that has been categorized. The where, which is like what's my matching condition. So the event code 4697. The 4697 is the new service creation event, and I want a service name with a pattern. So I'm using the regex. And their pattern that they were using is pretty simple. Once I've found a match there, so just uppercase A to Z. That was basically a length of 6. But to include that, there's also they randomized the binary that was in the service path. So in that, basically, I'm just saying, hey, I got another regex, and I said look for that service name pattern, but I also want you to look for that in the service path that matches .exes and bats. So in that Jinja template, I am basically simulating the same thing from the service names to the service path. So I have the randomization of EXEs and bats. So that all that's built in. So it gives you tons of flexibility. So let's go to the last one. I probably over time, so I'll wrap this up pretty quick. Alert stacking. So I use this technique a lot. Are we out of time?
Get
Close, but we're just coming in
We're
just
just here
just to say
support.
hi.
Just to say
Hi. Okay, but
Yeah,
if
keep
we're out of
going.
time, we're out of time. It's all good. Okay, so I'll just spit it off real quick. I won't go over the syntax as much, but this is alert stacking. And what we do is basically look at the alerts index itself. And I look at the rules that have fired over time. And I do a statistics crunch on it to identify how many unique alerts have fired per user. And when we do something like that, that gives us a lot of flexibility when we talk about noise. What do I see for this user? And I want to stack it. And if there's 3 or more alerts that have fired per this user within a short period of time, alert, right? That's that sequencing, that preset that I set, and it just fires off. There they are. Boom, boom. That's when I did it manually, and that's when I did it with preset. What? All right. Do I need to stop here?
you can keep going.
Okay, keep going. I'll do it. Let's do the wrap up. Let me change slides real quick. Where is it? Where is it? Killing me. Now you guys made me nervous.
Do you want us to leave?
No.
Okay.
I'm right there. I'm at
Okay.
that peak. Gotta do it. But if you guys need to like start wrapping up stuff, that's fine too. It's all good.
Nah, don't let's distract you.
Yeah.
I'm distracted now. Like,
Dang it, Jason.
I know
Go
we've
ahead.
never thrown
Go
someone
ahead.
off with this.
So
Go
bad.
ahead.
Yeah.
Here, I'll give you a moment to catch yourself. So for all of you that joined us today, thank you so much for being here. If you have questions, feel free to ask them inside Zoom. We'll do the best we can to get to them, a little post banter action. Feel free to ask those questions in Discord, and we'll see if Hal can jump in there at some point in the future and just respond to your individual questions. Also, your questions help us flesh out future content like blogs and other webcasts. So any questions that you have might be the reason why Hal goes, oh, I never thought of that. And he adds another 10 to 15 minutes to his next webcast, or he writes a follow-up blog to this. Also, that dance scene in Wolf of Wall Street is one of the best. It just is. All right. So Hal, with your recap, go ahead, sir.
All right, recap it. Let's take control of verification phase. Let's decrease detection release time. Let's save money, detect faster, defend sooner. I got another slide. One more. Questions. What's next? Well, with everything, it needs more work. So I need to add additional Windows templates. I want to support M365 to the unified audit log and basically have ways to generate that as well. Today I published all the code on GitHub, so feel free to take a look and play with it. Happy to hear from you. Done.
Well done. Good job. Good job, Al.
Good job, Hal.
Yeah.
Yeah,
Yeah.
well done. You're done.
All right. So for everyone that's still here, if you ever need our SOC services, they are available. Every once in a while, people are like, "Oh, you guys have services?" Yes. We're not just a comic book making, zine producing.
Card, deck creating,
Yeah.
t-shirt making.
Yeah, we also provide services. In fact, those services do provide the resources we need to make all the other stuff that we do.
Very true.
All right, Hal, if you were going to sum up everything you just said, and you did, right? Like, but now, if you were to sum up everything in one final thought that everyone could take with them, what would that be?
Oh man, I already did my thing.
In case you miss it, every once in a while, someone's like
Yeah.
driving home, and you're already home, but they're like, I wish I would have said. Is there anything you wish you would have said? Anything that you left on the field?
No, I think I put it all out there, man.
All right. So what we're going to do now is we're going to say, hey, thank you so much for joining us today. We're going to end the webcast officially. And now we're going to go into post-show banter where we're going to answer questions. So if you have questions, feel free to ask them now. All right, Hal, first question. Would this work with Exabeam?
So how it's designed with JSON. I mean, technically, right now it would not support Exabeam, but if I can add that. It's not that big of a deal. I just have to find out what's their if they take JSON files for ingest, it's gonna be easily added. But if they have some type of custom import, then it might be a little bit more difficult. But typically, most of them all accept JSON, and if that's the case, it should be easily addable to Exabeam.
And for everyone that's still here, if you forgot to check in for Hackett, you can
Yes.
do that now. If you don't know what Hackett is, then come to a future webcast. We'll explain it in greater detail.
And JSON, not Jason, right?
Yeah,
J-
not Jason.
Okay.
All right. Deb, do you have any others?
Kitty the turkey asked, will you be making templates for cloud related events?
Absolutely, that's definitely on my
Great.
list to do.
Okay. This one was when you say it only works with Elastic, you mean Elastic FileBeat /logstash only, not Elastic SIM, right?
So right, so we talk about FileBeat. That's that log collector that's taking that custom written log, and then it's sending it up to Elastic.
How many times, this is a question for me, how many times did you fail at making this before you actually finished making it?
I mean, I was still coding like a couple days ago, so.
Dude, I don't know if this works in coding and tool making, but in like content creation and writing, they say the best thing you can do to become a better writer is to publish work and know that people are reading your crappy writing. Is there something similar to tool making and coding?
Yeah, so basically now this is on GitHub. There will probably be issue requests like, hey, you got a problem with this code. So that's going to be my critique on my code.
Got more work to do.
All right. Other
Yeah, I
questions?
don't see any other questions, but yeah, if we missed your question, please feel free to.
This question did come up a few times. What about your detection engineering unleashed class? You mentioned it, but what's the next steps for that?
So I had to do a couple other webcasts. So there's an anti-cast, and I'm going to do a workshop. So if there's something that interests you that I might not cover in my class, I might do it in one of those. I might do it in the anti-cast, or I might do it in the workshop, which is basically all free, just like today. So that basically is going to be the next steps. That's going to happen in August, and then soon after that, I'll probably have a release for the class.
Yeah. All right. And then for those of you that were here at the very beginning, we had a contest. We'll get that mailed out to the winners. And then if you are available next Wednesday, and this shouldn't be in the recording, so if you're like watching this in the past or something, or the future, but next Wednesday, May 14th, we'll be in Annapolis, Maryland. On May 15th, we'll be in Cary, North Carolina. And then on Saturday, we'll be in Tampa and Orlando to do comic book signings for the new comic book series, The Future Is, which is right behind me. It takes place in the future. It's like Mission Impossible meets Black Mirror. And so it's going to be a lot of fun. We got 60 issues coming out over the next 5 years. Issue number 1 comes out on May 28th. And so if you would like to get that, you can go to your local comic shop on May 28th. Like, you can go to your local comic shop. It's a real comic. All right, Hal. Anything else? Troy, anything else?
Good.
Oh, here's one.
Cool.
Just snuck in. Can we contribute to the project? If I wanted to build a generator for Linux logs or network logs, or build an output for Splunk, can I submit a PR, or are you working through those right now and don't yet need the contribution?
Well, I mean, you can message me. We could talk offline, but I do plan on building that out. But I don't mind like people helping me out either.
Yeah. All right, Hal. Thank you, Hal, for putting all this together. Thank you for choosing to share knowledge. Thank you for making tools and making them available to the community. It's how we all get better together. And so if you joined us here on Discord, or this is your first time, come back. We don't have a webcast next Thursday, but we do have one the Thursday after that, and then the Thursday after that, and the Thursday after that. So thank you so much for your time today. I know you could do anything. Speaking of which, Deb, what are your final thoughts?
That's what I always say. There's so much noise out there. There's so many things that you could give your time and your energy to. And we always appreciate that you give us an hour and a half, sometimes 2 hours on Wednesdays and Thursdays. So we don't take it for granted. Thank you for choosing to show up, because we love interacting with you guys. So that's all.
Yep. All right, everybody. We'll see y'all next time. All right, Megan. Kill it with fire, Megan. Kill it.
Good.